So today's problem of the day on the Leetcode is minimum number of operations to move all balls to each box. So in this problem, what we have and what we need to do, let's see it first. So first of all, we have given n boxes, which is actually each character in a string name boxes. Okay, so you have given a binary string. That string, actually each character of that string shows one box. Initially, each box can contain either one ball or it might be empty. So 1 basically shows that it contains one ball, and 0 basically shows that it is an empty box. Now what they require us to do is, we can perform one operation. In that one operation, we can only take one ball from any of the box and move it to its adjacent box, either left or right if possible. So like I minus 1 or I minus j, I plus 1 or I minus 1. So this movement takes one operation. What we require to do is, we have to give or return an array in which we have to show that if first box need to be filled with every single ball that is present in all the different boxes, how many operations, minimum operations required. Similarly, if second box need to fill with all the balls that is present here and there, how many balls, how many operations required. And similarly the third, here is also like first, second, third and fourth. So actually we have a trade-off here. If we require it to do in minimum space complexity, then it will contain a time complexity of O big O of n square, which can be done easily with the brute force of 2 for loops, nested loops. Like we can take this one first box like 0 0 1 0 1 1. So what we can do is, we can take first box and iterate over all other box and see its distance from this, like j minus I, simply like j minus I. Okay, or and then sum it up. Similarly from here we'll sum it up, then from third box, then fourth, and then fifth and sixth. But we don't want to do this. Have the like My target is to have a better time complexity rather than the space complexity. So what we can do is, yesterday also and day before yesterday, we have continuous 3 problems in which there is some query and we need to do the pre-calculation before doing all those queries. So it is also the similar type of question in which we have been required to calculate for every single box somehow using some pre-calculative method. So what is coming in my mind is again the prefix sum type of array. So I will explain in the coding. So let's say we have, let's say we require one array int a which will contain of s dot similar length comma 0. Okay, uh, so what I will do is, we will take count of every total number of balls till that index. Okay, so what we are going to do is, let's say 1 1, let's say 0 0 1 0 1 1. So in the first step, here is no ball at all, so this ball need to shift here, requires 0 movement. Means first ball inside the first box need at least 0 movements. Okay, similarly for, like say, second box, before that we don't have any balls, so minimum number of operations for moving the first ball to the second box require 0 movements again. Okay, and similarly let's say the third box. So third box we already have one ball present, and before that there are none of the balls present, so it will again take 0 moments, 0 operations, or you can say 0 operation. Okay, so but for the fourth box, let's say in the fourth box we need to move all the balls from the first to the fourth box. So for moving all the balls from first, second, third box, we need to move it to the fourth box. So fourth box we have only one ball, so in this one ball which is just adjacent, it require only one operation. And similarly fifth box and sixth. Let's move to the sixth box. Sixth box will have total number of balls, which is z1 and 2. There are two balls before that, and operations required to move this ball up to this is 2. So this is 2 plus 1 of this, so total will be 3. So let me code it and you will understand. It's just simple prefix, huh? So for int I equals to 0, I less than, let's start with 1. Okay, I less than s dot length and I plus plus. As I said, we will take count equals to 0, and if s0 equals to 1, it will be count equals to 1. Okay, so what we will do is nothing, just simple thing, that is a of I will be the total number of operations required just before that box, or just before that index, plus all the balls that are collected till the box I minus 1. They all require one more movement. So let's say just before that we have 6 balls, so now we will require 6 operation, so total number of balls. Okay, and if now this si also contain one ball, then we will increase our count of balls. Simple. Okay, but this will not give us the answer, because we have to calculate for the movement of all the left to right, but from all the right to left. Let's say for index 1, for index 2 we need to require calculation of all these balls moving to the left side. So we will again define a new vector which will have same features, comma 0, but we will calculate it from other side, from the right side, or from the ending to the first index. So if s dot length minus 1 equals to 1, then count equals to 1, and we'll move from s dot length minus 2, I greater than equals to 0, and I minus minus. Here our bi will be b of I plus 1, which is already pre-calculated operations moving all the balls from right side to up to that index, plus count. And if again si equals to 1, then we will increase the count. Simple. Now we have all the pre-calculated operations for moving all the balls from left to right or from right to left. Now we just have to combine them in the answer, or we might not require a new array. So let's say I less than s dot length, a dot length will also work, a dot size, actually it is an array, and I plus plus. Okay, so ai will be a of I plus b of I. Simple. And we will just return a. Let's see. So we got like almost 0 millisecond of runtime, beating 68 to 90% of people. So our so what we did is trade off here is with space complexity. So with the space complexity we have traded off, and we have big O of n space complexity and big O of n time complexity. But if we go for the 4 and 4 two nested loops, then we will have big O of n square as time complexity and big O of 1 as space complexity. So we have traded off and for a faster code. So see you guys, tata, bye bye, take care.